Hi, we're a team composed by Victor Lima, Carlos Acosta, and me, Jose Menendez, and we're going to talk about secure SMS encryption using RSA encryption algorithm on an Android message application. Well, first of all, uh, let's talk about the messaging in the modern landscape of technology. Well, it's fair to say that everyone texts, everybody sends messages, everybody sends pictures, images, or any kind of information through the web or through a connection with each other. So this type of interaction has to be secure, confidential, and simple because it's everyone uses it, from older people to younger people to every kind of human being uses this kind of technology and exchanges all type of information, messages. As I said, there are a lot of types of multimedia that can be shared or information like texts, images, videos, um, and all kind of even money with this type of exchange. So people behind these applications, behind this website, behind this software, have to be they have to create protocols and mechanisms to protect the information and make it go from one way of the communication to the other without any kind of trouble, without any kind of intruder getting into it, and well, make it safe, secure, and confidential. And that's what brings us to RSA. Uh, RSA, it's an algorithm created in 1978 by Ron Rivest, Adil Samir, and Leonard Adelman. The name comes from the first initial of every last name of these researchers, of these engineers. And R from Rivest, S from Samir, and A from Adelman. And well, in what does RSA consist? It consists in an asymmetric cryptography algorithm which uses public and private keys to make operations and this way transform a plain text into a ciphertext and vice versa. These operations will be talked about more in depth in the presentation of the code, but it's fair to say that it relies the difficulty of this algorithm on the generation of these keys by factoring and using large prime numbers, because by using these large prime numbers, these keys are generated, and the larger the number are, the keys are more secure, and they are better to be able to transform um, the messages, and this way making it harder for intruders to get them and decrypt them and being able to know what they say. So there lies the complexity of RSA in the large prime numbers and the generation of keys. Now, let's talk about the current state of the RSA. Uh, it has to be said that the 1024-bit keys are not that secure anymore because they can be cracked more easily. And that's why the current standard is the double, like 2048-bit keys. That's why government uses and a lot of protocols use, because a lot of modern day protocols use RSA. So that is why the lower bit keys are not used anymore, because they're not that secure. They can be cracked more easily, and that is why there is a research right now going on to look for bigger keys, like it's the case of a 4098 96-bit key, which a group of researchers have achieved. Um, it has to be said that in this group of researchers, one of the main of the main creators of RSA was working in this, and it's Samir. And well, they generated this other key, which is bigger than the 2048 one. And well, also another aspect in the modern landscape of uh, public key cryptography is that there are alternatives like the elliptic curve cryptology. Uh, and that's why this is a good alternative that a lot of people are using, because it makes faster, smaller, and more efficient keys than the RSA. And well, it has to say that this type of technology has to be taken into account, because in the modern world of technology, uh, an alternative can take the place of the other technology in just a blink of an eye. So we have taken into account that there are new technologies that are that are gaining ground in the space of public key cryptography. Well, now I will give an overview of our mobile application. It has to be said that it was developed in Python using the Kivy framework, which is a framework that allows users and developers to create mobile applications using Python. And well, this gave us several advantages, like creating this application as simple and as useful as possible, using all and getting the results that we wanted. Well, now let me explain. The app.python program, it includes all the views and the pages of the application. Like you can see here, we have the scrollable label, which has the different sides, heights. Sorry, different heights, different uh, behaviors of the application when several messages are coming through, like the chat history. Like you can see here, we have the height of the layout, the chat history, the height, the text size, like all these different characteristics, like of the front end of the application, we have it here. Um, as you can see, there are different, the width, the height, and all the text sizes are in this section. The first class, as I said, that was scrollable label. The second one is the connection page, which it entails using a .txt file using the operating system library. This way, our program will be able to get to this text file and getting the different information that we need. In this case, our text file that is called prefdetails.txt. It includes an IP address, a port, and a username. Like it says here, it opens the file, it splits the file using the comma as a separator, and well, it gets the IP, the port, and the username. This way, it can put each one of these data. You can put them in their respective place. Like in the case of the IP, it will go with the text input of the IP, the username with the username, and the port with the port. And this way, we will join them later by using all this information that we got from the txt file. Like I said, you join them using a join button that is right here, in which it gives you the port, the IP, and the username, and it joins them in the information screen that we will talk about later. On the other hand, we also have in this class we have the connection, which uses the port, the IP, and the username as well. And well, if the connection cannot be made, then nothing will happen. But if the connection can, well, it will show the error. But if the connection is made, the application will create the chat page, and it will send us to the chat page. And well, after that we have the info page, which, as I said, we have all the labels, all the different width, height, text sizes, and all of those characteristics. We have them here. And well, the update information, which is like updating the message that has come through. And well, then we have the different characteristics that I said. Then we have like the whole chat application build, and that's what it says right here. It has like all these components like we talked about later, the connect page, the info page, the chat page, and everything. And well, this is the class that creates all and puts it all together. Um, then we have another component, like I said, the chat page, which has a history, which uses a scrollable label class, well, an object of that class that we saw previously, which is the one that makes if the text is too big, you can scroll through it. So yeah, well, if the components are too big, you can scroll through them. And well, as well, we have all the different characteristics of the layout, how it's going to behave when something happens, like when there are many messages, when you need to adjust the fields because they are too big, and well, all of that little aspects that have to go into developing a front end of an application. Um, like I said, there are different behaviors like the key down to send well the message. and well, the send message, which is it gets the message and it changes the color of the chat history once you send the message. That's what it says here. It changes the color, and well as when an incoming message comes, it also changes the color. When a new text comes, it focuses on it. And well, finally, we have like the error. If something happens, it will show a message of error showing that something happened. On the other hand, we have the socket client, in which we've got the creation of a client and connecting it to a server. First of all, we create a socket with an IP version 4 protocol, which it can be seen here with the socket.af inet, and where we use a TCP connection based socket, like it can be seen here. And well, with the given port and IP, we try to connect. If the connection cannot be made, it will throw an error. And well, then if a connection is made, we have the username and we encode it, as well as the header, which is a fixed size header. And well, the client sends the username, the header and the username encoded. So well, as it can be seen, the client can send a message by this function, in which the message is encoded with a header size that is fixed, like I said previously. And where you send as you sent previously, we sent the username header and the username, and now we send the message header with the message. And well, it start listening. That's why that's how the client starts listening if a new message arrives. And an error callback is when something may happen during that listening of new connections. Um, well, as I said before, now we have another kind of the listen function, in which we loop through the incoming messages. That's why we have this while true, and that's why we're looping over these messages in which we receive the header of the username with the header length that is fixed, like I said previously. And well, if there is no data, we close the connection. Then we convert the header to an integer value in order to then receive and well decrypt and decode, better said, this username header. And well, after we receive the header of the username and we decode it, and then we do the same for the message. We get the message, we get the length, we transform it into an integer, and then we decode it so we can see, and we print it as an incoming message, as we can see here. Finally, if there are any exception, we get this error and the program exits. Finally, we have the socket server part of the program, in which we configure a server socket, which will get all the new connections and will get the messages that are being sent from one socket to another. That way, we can see that we create a socket with an address family of IP version 4, and we use a TCP connection-based protocol. Well, these are all the setup for the server. As you can see, we bind the IP and the port, which can be seen up here. The header length is 10. And well, this function makes the server start listening for new connections. We create a list of sockets and a list of clients which will include the usernames, the header, and well, the user header, the name, and the socket as key. And we print that we're ready to listen to new connections. To receive a message, this function was created, in which we will try to receive the header containing the length of the message, which is defined and constant. If there is no data in the message, we will return false, and well, in otherwise, we will take the header and convert it into an integer, like we did in the socket client.py. After the message is received, we create an object with the header and the data, which is the message data. Um, if we have an exception in case the user closes the connection violently, like it's the case of Control C, or just closes the program, and that's why we have this exception. But in other case, we iterate over the notified sockets, like it's the case in this for loop. If we have a new connection, we accept it if we have the client socket and the address, and where we have to receive the name right away. If we don't receive the name, it will enter this false if, because we need to receive the name before this connection. After the socket is connected, it is added to the socket list and to the client list with all the data that it entails. Um, After it is connected, we print the message that we accept the new connection with all the data from this new client. Um, if an existing socket is sending a message, we have this else, in which um, if the client is disconnected, we will close the connection and we will show the information of the client that was disconnected, and we will remove it from our both lists. Um, if there is no disconnection, we will we will print the message that a message has been received from the user, and well, the message that was being sent. Um, if After that we iterate over the different connected sockets, well, the connected clients, I'm sorry, and well, we broadcast this message through them. And uh, well, we iterate over them, but we don't send it to the one who sent it. If We send it to everyone but the one who sent it, and that is why we we save the information and we keep it from going to the same send to the one who sent it. Um, Finally, we have this exception that will, just in case there is some weird exceptions going on, we have this section right here.
Hi, I am Carlos Acosta and I'm going to talk about RSA algorithm and how it works. So, first thing that the RSA algorithm needs to work each time a user enters or generates its login, it's to create both a public and a private key. The public key is a key that the rest of the users will use to send information to this specific user, such that they're going to take this public key, encrypt the information using it, and the private key is the key that only the user will have. It will be secret for only to this user, and he will use it to decrypt the information that all the other users send to them. It is important to note that both the public key and the private key are mathematically related since they were created from the same base. So this is the reason why we can use both keys to encrypt and decrypt the information. So let's take a look on how the algorithm works and how we generate these keys and how we encrypt messages. So first thing that we need to do is to generate the public and the private key. How this happens? We need to take two prime numbers. It is preferred to have really big numbers since the bigger the number, the more complex it will be the computations needed to decrypt the message, and this will ensure a more secure encryption. But we're using these two numbers just to make an example on how the algorithm works. Second thing that we need to do is to calculate a number n that will be the product of multiplying p and q. Then we need to take the phi of that number, with that which be uh, taking away one from P and one from Q, and multiplying those two new numbers to get a new number that will be the phi. Once we have n and phi, we need to pass this phi to generate the letter E and the variable D. So how does these two variables are computed? So we're going to talk about now how E number is calculated. First, we need to start with an E and with an array. This array is because there are multiple options when we are generating the number e, so we can choose any of them, and that's what we're going to do actually. Uh, what we're doing here is that we're checking for each possible number that e can have, such that the e must be a number less than 5, but at the same time, its greater common divisor between e and 5 must be 1. Once this criteria is accomplished with the e number, we will append it in our array, and we will try each possible number. Once we have all possible numbers that the e can take, what we're going to do next is to choose randomly one of these numbers. This will be random because we need to ensure that the encryption is as secure as possible, and we don't want to take a default value, so that each user can have a unique password, even if we are still using repeated prime numbers with each user. So that's how we computate the e variable. But now we need to know how do we computate the d variable, which will be for the private key. This is by doing a similar process with e. Um, what we need to do is to computate d such that the multiplication of d and e has a result of 1 when we calculate the modulus by phi. To say it more clear, if we computate the multiplication d and e, we need to obtain a number that when we calculate the modulus of phi n, we obtain a result of 1. Once we find this specific number that it is based on e, that is why we need to make e random. That is a moment when we have our two keys, which are n, the first number that we computed with our prime numbers. The public key will be based on n and e, and the private key will be based on n and d. So once we have both our keys, we need to understand how messages are actually encrypted. What it is happening is that each time a message is passed, we need to consider that each letter has a value in the ASCII table. This is important because this value is the one that we are going to use to encrypt the message. What is happening is that this value is an integer. So to encrypt each letter, we need to pass this ASCII value. We need to elevate it. In the case of the public key, to encrypt it, we need to elevate this ASCII value to the to e, and once we have that result, we need to calculate the modulus n. That way we're going to get a number that is encrypting our first letter, and we're going to repeat this same process with each letter of the message. As we can see, what we're doing is that we're receiving a message with the public key that is going to be used to encrypt the message. We're going to split the message into words. We're going to append those words, and then we're going to repeat a similar process to encrypt each letter on the word, such that we're getting a message totally encrypted letter by letter using this public key. Now, to decrypt the message is a similar process, but what we are doing is that we are receiving the numbers that we previously encrypted. We're going to take each number, and then what we're going to do is to calculate a similar operation than the one that we used to encrypt the letter. So what we're going to do is to elevate this cipher letter to to D, and once we elevate that number, we're going to calculate the modulus n, as we can see here, and that way we're going to get back the ASCII value for that specific letter. Once we have the ASCII values, we now have to look in the ASCII table what is the value for that ASCII, and that way we're going to get back our letter. Once we have retrieved all the letters of the message, we will end with the original message, and we can see an example on how this works. So if we encrypt a message such like information security is important on SMS exchange, what will happen is that each letter will be encrypted using our numbers, our keys, and we're going to get numbers that we cannot know if they're numbers, they're letters, they're symbols, because they're encrypted with two prime numbers, and the computations needed to know which prime numbers were used to generate this key would be really long, and it would be almost impossible. The best way to know these keys would be by trying to guess. But if we use our private key and we decrypt each number, what we're going to get is our original message, and that way is um, uh, the how we encrypt and decrypt message. And this is the reason why this is such a good method to encrypt information when we are using a communication line.
Okay, hi, I'm Victor and I'm gonna present to you the implementation of our application with the RSA algorithm for the encryption of the messages. First, we have to initialize our server. Here you can see it with Python socket server.py. That's how we initialize our server. And now we're gonna create two instances of our application in different command lines. So we say Python app under is we are using Kivy framework to create this application. It's a great framework to create a graphic user interface in Python. And actually, these applications can be exported and published to Android, to iOS, to Mac OS, to Windows, to basically any system, to Linux too. That's how powerful this framework is. But for to explain the operation of our system, we are gonna use two instances here in the. So yeah, as you can see, I created one instance of my application. It has the IP address and port of the server we are going to connect with, and a username. In this case, it's Victor. I'm joining, great. That's it. Here we have our first application. Let's do it with other. There it is. We'll create another user because speakers are already online. So Charlie, same IP, same port because we are connecting to the server, to the application server. So Charlie joining. Actually, in the server page, you can see those little notifications that someone uh, entered or went out of the chat. Now we are going to test our application. As you can see, in this button, I can access all the users that are online. So I press Victor, here is the Charlie's chat, and say, hey, Victor, this is Charlie, and send. As you can see here, well, the message is already sent. Here it says Charlie sent a message. Hey Victor, it's Charlie. Here too. So Victor received the message, and maybe in the application it's not. It doesn't seem like something happened. But if you go here, if you see under my window, you can see in the command line how looks the cipher text and how it looks when we decipher it, when we decrypt it with RSA algorithm. So I'm gonna show you how it works. In the socket client, we create our RSA keys or private and public keys, and we send in a message along with our username or public key. That's how it works for all users. So when anyone enters the chat, they connect and they receive a first message from the server that will have this as username, where username just we are using the username just to keep with the way we are sending the messages through our sockets. So if the username is this, it's a flag, uh, then it's not a message what we are receiving, but a dictionary with all the keys of the users that are online right now. So in that way, when we want to send a message here, we just have to send the message itself with the user we want to send it to, and well, the key of that user. So back to our client socket here, we when we send the message, we are sending the user plus the message, all concatenated in an only string that will be split later in the server, and we send the name of the user. But before this, we encrypt that message, as you can see here, in cipher RSA cipher. Here, our message is encrypted, so it will travel through the net encrypted, and we'll get here to the socket server. With the username, the socket will know who user should be sent to, and well, it will get it back to our client instance, of course, in another for the user that is receiving the message. Here, the user, if it's a flag, well, it won't decrypt it because it's not something it's not encrypted. But if it's not a flag, then it will get the ciphertext and convert it to a plain text with the decrypted algorithm of RSA. And that's how it works. Thank you.